So let's begin with our first question. So here I have written something. So this is the question, right? You will find this question in the description box also. There is a link to a Google Doc. You can save the link to that Google Doc, because in every video you might find that link, and in that video, that particular Google Doc, I have many questions written. You can try them, and more will be updated regularly. So here I have written what is a good code. So that is very essential when we are solving questions in interview point of view, because in a good code we have to care about three things, that is time complexity, space complexity, and readability, right? So our code should take as much less time as we can, so the complexity should be less, and space complexity, that it should take up less memory space in our system, and the code should be readable. For example, here I have initialized the array as array, right, variable, and the given number. Okay, let me first tell you what is the question. So the question is that we are given with a sorted array, right, with a sorted array, and we are given with a number, and what is the relation between them? So we have to find two numbers in the sorted array which is equal, which sum is equal, which sum is equal to the given number, right? So in this particular code, what we are doing here is that we are going to write it in two different methods, and we will explain what is the importance of time complexity, right? So this is the exam, like this question is for that only. I have given this question to make you understand what is the how you can solve the same problem with different time complexity, and we have to choose the better one, right? So let me now write my first problem. This first problem I have already written here. This is given one sorted array, and we have to find two numbers which is equal to a given number. So this is the given array, this sorted, and this is the given number. So this is 28, so our numbers should be 11 and 17, right? And here I could have also used variable name like a, and this given number like b, but what is the problem here? For example, our code is 60-70 lines, and for example we are going in a very, like, at 50th line or 60th line there is mentioned that b, or you can say there is operation, there is b and a are like mentioned in the 50th or 60th line. So someone who is reading our code, he will have to again scroll back to the top to understand what is b and what is a, because a and b are nothing but references. But if we make the references like something common, like we can say this is array, if we are having two array, we can name one is array 1 and another is array 2. So this makes the code more readable. So as long we are having a small code, then mentioning variables like a, b, it's okay. But if we are having a long code, then to make the code readable, we have to use common names like array, given, constant, counter, like that, right? Okay, so depending upon the situation, after completion of this course, you will be having more hands on this good code. You will be able to write good codes. So for now, let us hop on to our first method. So here I am starting I from 0 till the last index, and incrementing I after each loop. And again what I am doing, I am starting j from I plus 1 till the last index. I will make you understand, and incrementing it after each loop, and I will say if ith index number plus jth index number is equal to given, or is equal to given number, what I will do, I will simply return equal to, this is like comparison, not assign. So if this happens, so we will print the numbers are the number at ith index and the number at jth index, right. So this will work. When I run this code, I will get the numbers are 11 and 17, but the problem is here that this particular loop runs for n times, and for each time, like this is running for n times. So how many times this loop will run? This loop will run for n square times. Why? Because it will run for actually n square time. Let me first write it, because see this for I is equal to 0, this will run from I plus 1 till the last position, and for I is equal to 1, this will run for I plus 1, that is from second index till last position, and so on. So this will be n into n, that is order of n square. So how this code is functioning, let me make you understand. So what I am doing, I am comparing, like I am taking I is equal to 0, and I am starting j from the next index to I, that is what I have written here, I plus 1. So this is comparing the ith index with I plus first index, I plus second index, and so on till last index, and then it is increasing the I value by 1. So it is now comparing the first index with second index, third index, and so on. So this will run till 11 and 17 are compared, and we get our desired result that the numbers are 11 and 17. But actually this method overally, the time complexity is order of n square, which is a very costly method. So what we will do, we will write another method, and here actually you have to be bit vigilant of what I am writing. You have to understand, if you had seen my other videos, so I write a pretty similar code for reversing the array. So here also we are writing the same. So what we are doing, we are initializing I as the first index and j as the last index. Okay, so n minus 1 is the last index. So the I and j is initialized, and what I am doing, I am writing a while loop, writing while I is less than j. What I am doing, if the number at ith index plus the number at jth index is equal to the given number, what I will do, I will print, I will simply print this which I printed earlier. Okay. Else if the number at ith index plus the number at jth index is greater than the given number, here the thing is tricky, and another else. So here the thing is tricky. So as this array is sorted, you remember what happens, like what I am doing, if 1 plus 17, see here 1 plus 17 is actually 18, which is less than 28. So if I decrease the value of j, which is pointing at 17, this will be 1 plus 11, right. So 1 plus 11 will be equal to 12. So the value is decreasing more. So if we keep on increasing the value of I, if the sum is less, then we will get a greater sum, because this array is sorted. As we move, like let I plus j is a constant, so this sum will increase if I value will increase, because I value is now pointing at a smaller value, and with time it will with increasing it will point at a larger value. Similarly, if we want to decrease the value, what we will do, we will simply decrease the value of j, because j is now pointing at a larger value. So as we will decrease, this I plus j will decrease, right. I hope you are understanding this. So so if the sum is greater than given, so we will decrease the value of j, right, and if the sum is less than, only one possibility left, If the sum is less, so we will increase the value of I, so that we will get a greater sum. And now if I run it, I will get the similar answer, but you see this loop prints for infinity. Why infinity? Let me close it. Why infinity? So what I have to do here is I have to use a break statement, because without break statement, what is happening if I am not using this break? So when array of I plus or ith element in array and jth element in array, their sum is equal to given, so this particular thing is getting printed, and I value and j value is not incremented or decremented. So again the same thing, this while loop checks that I is less than j, again it is true, so this thing gets printed again and again, so we will get a infinite loop. So by using this break we will not get infinite loop. Let me simply run it. So yes, so 11, 17 is are our numbers which will give us 28. For example, we are writing say 7 plus 4, that is 11. So here we are simply writing 11, and if we are printing we will get 4 and 7. So the time complexity of this very code is order of n. Why order of n? So what it is doing, it is checking, what it is doing, let this is the I, so first I value marks here and j value at the last index, these are the counters. So it will check if 1 plus 17 is equal to 28, no, then what it was 20, or let it be 11. So 1 plus 17 is equal to 11, no, and if 1 plus 17 is greater than 11, yes. So what it will do, it will decrease the j value. Now j will not refer to 17, or array j will refer to this index. So now array jth index will contain 11. So now 1 plus 11 is equal to 12, which is again greater than 11. So again we will decrease the value. So now j will refer to 8. Now 1 plus 8 is equal to 9, which is less than 11. So now I value will increase, because we have to make the sum greater. So now I will refer to 2. Now 2 plus 8 will refer to 2 plus 8 will refer to 10, which is again less. So now this will refer to 4. So now 4 plus 8 is 12, which is again greater than 11. So now j will decrease. Now j will refer to 7. Now 4 plus 7 is equal to 11. So this 11 will be printed. This numbers are 4 and 7, and we will break our while loop and we will get this output. So I hope you understood. So this was actually to make you understand the difference between a higher complexity and a lower complexity problem, the same problem with different complexities. So this was of order of n square time, and this was order of n times. So this is how we will define that if the complexity is higher, it will take more time to solve, and it is not a good code, right? If the thing can be solved within less amount of like time, then it is better, okay, it is more efficient. So that's all for this video. In the next video we will discuss the other problem. Thank you.